Hello students, welcome back to our channel Deeksha Karnataka. So as you all know, we have started the mock test series. So we are having all the 3 free mock tests for you for your COMEDK preparation. So in this video, I'll be discussing the solutions of mock test 1, chemistry part 1, which consists of the first 30 questions. Okay. So the PDF of the question paper is available in our WhatsApp channel. So please join the WhatsApp channel. The link of the WhatsApp channel is there in the description section of this video. So please go there, join the channel and then download the question paper, solve the question paper and then come back to check the solutions. Okay. So there is no point of seeing the solutions directly without trying by your own. Okay. So this mock test is designed to understand your level of preparedness. So please first attempt it honestly in exam conditions and then come back to check the solutions and to know your level of preparedness for the exam. Okay, so let us start with the first question here. Okay, so the first question is from your biomolecules chapter. Okay, so which of the following diseases is not correctly matched with the vitamins mentioned with it? So in the biomolecules chapter in vitamins and hormones topic, this is very important that you prepare the deficiency diseases of each and every vitamins. Okay, so in NCERT one table is there, you have to learn it, remember it. And for hormones, just go through the hormones part and note down the functions of each and every hormone. Okay. So now coming to this one here, vitamin B2, cracking of lips, vitamin C, bone deformities, vitamin D, osteomalacia, and vitamin A, night blindness. So you know vitamin C is the cause for deficiency of vitamin C is the cause of scurvy. So the not correctly matched is your option number B. Okay. Next question. Okay, so here is the announcement that we have started a free mock test series. There will be 3 mock tests in this series for your COMEDK preparation, which is absolutely free. And these, already the first mock test has been released on 29th April. So you will be getting all the question paper in our WhatsApp channel. So please join the WhatsApp channel. It is very important to get the PDF solutions and the video links of the solutions. Everything will be there. All updates you will get. So the link of the WhatsApp channel is there in the description section. Please go there, join it and then attempt the mock test. Okay. So the solution PDF of this one of this first mock test, which was released on 29th April, will be released on your 1st May evening 5:30 p.m. So please go there and check the solutions. Okay. So for that, don't forget to join our WhatsApp channel. So now let us go to the next question. The reaction of toluene with chlorine in presence of FeCl3 gives predominantly. So if we have toluene and you are reacting with chlorine in presence of FeCl3, right? So this is chlorination of the benzene. So it is ortho-para directing group. So we will get substituents at the ortho and para position. So we'll get a mixture of ortho and para chlorotoluene. So the correct answer for this question is option number A. Again, direct question. So this question is from your, I can say, haloalkanes chapter. Next, okay, this question is important. The number of moles of KMnO4 that will be needed to react completely with 1 mole of ferrous oxalate in acidic solution is. So this question is from your DNF block. Okay. So in DNF block, especially KMnO4 and K2Cr2O7 reactions are given. That is important. So let us see here. Ferrous oxalate is given, right? So what is the reaction for ferrous oxalate? Fe2 plus will get oxidized to Fe3 plus with 1 electron. Oxalate is C2O4 2 minus will get converted to 2CO2 with 2 electrons, right? Now this we know permanganate is what? It is an oxidizing agent, so it will get reduced. So if I write the reaction for MnO4 minus, so MnO4 minus will get converted to Mn2 plus. Okay, so we have here 2. For balancing this one, for balancing this 4 oxygen, we can add here 4 water. Okay. Now there will be 8H there, so I will add 8H plus this side. Now you see number of oxygen, number of electrons here is +7 to +2. So number of electrons I need is 5 electrons, right? So if I add these first 2 reactions, there are 3 electrons and here there is 5 electrons, right? So to balance out, this equation should be multiplied with 3 and this equation should be multiplied with 5. Okay, so now we will multiply both the equations and add it. So the final reaction that I'll get is we will have 5 Fe2 plus, okay, and we will have 5 C2O4 2 minus, okay, and then we will have 3 MnO4 minus, and then we will have 24 H plus. Okay, I completed all the left hand side. Now let us go to right hand side. Here we will have 5 Fe3 plus, okay, and we will have 10 CO2, okay, and then we will have 2 plus 3, total 3, 15 electrons. Here also we have 15 electrons, so electrons are getting cancelled. So next we will have is here 3 Mn2 plus, and we will have 12 water, okay. So you can see 24H, so the reaction is balanced. Now you see the question is asking the number of moles of KMnO4 required that will be needed to react completely with 1 mole of ferrous oxalate. So now if you see the balanced reaction that we have obtained, according to this, what I can say is 5 moles of ferrous oxalate is oxidized by 3 moles of KMnO4, right? So for 1 mole of KMnO4, how much it will be required? It will be 3 by 5 moles of ferrous oxalate, right? So the correct answer for this question is option number A, that is 3 by 5. Okay, so just check this one. Balancing is important to understand the stoichiometry here. Okay, now let us go to the next question. The ratio of radii of the first 3 of Bohr orbit. Okay, so ratio, what is the general formula of radius? So this question is from structure of atom. Okay, so Bohr's formula, radius formula is 0.53 n square by z, right? So this is the constant part, we need not worry, we'll only, so Rn is proportional to n square. So n square is the orbit, so we have first 3 orbit, right? First 3 orbit means R1 value will be 1 square by z, R2 value will be 2 square by z, and R3 value will be 3 square by z. Now if you take the ratio, this 0.53 and z will be get cancelled, so we'll get 1:4:9. That's the correct answer for this question will be option number C. Okay, next. The rate of the reaction, so this is from your chemical kinetics chapter, right? So the rate of the reaction is expressed in different ways as follows. The reaction is. So first of all, we have to understand here is for reactants, we have to use negative symbol, and for products, we should use positive symbol. And the number which is written here, that will be the coefficient of the reactant or the product. So now let us see here. So we have C plus, so C will be in the product side. How many C will be there? 2C, right? 2C we got. Next one. Here negative is there, that means D is in the reactant side. How many D? There is 3D. So 3D. Now coming to the next one, A. A, there is positive, so it is on the product side, and 4A will be produced. Next we have again negative here, B, that is a reactant, so 3D plus B. Okay. So now you can see which option is this one. 3D plus B gives 4A plus 2C. So the correct answer for this question is option number C. Now next, which of the following reactions are disproportionation reactions? So this question is again from your D and F block, or you can also say from redox reaction. So D and F block, because the compounds are transition elements. So disproportionation reaction is those reactions where the same element undergoes both oxidation and reduction. So if you see here, copper oxidation state is +1, here it goes +2, and here it goes 0. So both oxidation and reduction, so answer 1 will be there. So in which option? Option 1 is not there, we can eliminate that one. Now coming to C, here it is +6, okay, and here it is +7, and here it is +4. So here also from +6 to +7 is oxidation, +6 to +4 is reduction. So the same here, this also undergoes disproportionation reaction, so 2 is also there. So we can eliminate those options where 2 is not there. We can eliminate these two. Now we can check for 3. Option number 3, if you see this one, this is +7, right? So here it is from +7 to 2 plus x minus 8 equal to 0. So this is your +6, and here it is +4. So +7 to +6 is reduction, +7 to +4 is also reduction. So there is no oxidation in option number in the third reaction given. So this cannot be there. So the correct answer for this question is option number A, that is 1 and 2. Okay. Let us see the next question. So you have to match the following. Methanol is wood spirit, we know. So A is 4. So where A is 4, so we can eliminate these two options. Now coming to B, fermentation. So fermentation is there, and then let us see the next one. Conversion of secondary alcohol to ketone. So that is when heated under copper at 573 Kelvin. So C is your option number 2. So we can eliminate this one, and D, Williamson ether synthesis is reaction of alkyl halides with sodium alkoxide. So D will be your option number 3. So the correct answer for this question is option number C. Okay, once again you can see methanol is wood spirit. Okay, methanol is wood spirit. Then fermentation is ethyl alcohol. Conversion of secondary alcohols to ketone is your heated with copper. Williamson ether synthesis is reaction of alkyl halides with sodium alkoxide. Okay. Next question. Which of the following statement is not correct about an inert electrode in a cell? So it does not participate in the cell reaction. This is correct. That is the meaning why it is called as inert electrode. It provides the surface either for oxidation or for reduction reaction. That is also correct. It provides surface for the conduction of electrons. This is also correct. It provides the surface for redox reaction. This is incorrect. On the same electrode, either it can be reduction or it can be oxidation. It cannot have the surface for redox reaction. Okay, so this statement is incorrect. So correct answer for this question will be option number D. Now let us go to the next question. The condensation product of benzaldehyde and acetone. So we have, this is aldol condensation, very important. We have benzaldehyde and you have acetone, right? So what we have to do, we know the trick to find the product. So what you have to do, this is your alpha carbon. So you have to connect this carbon to this carbon, okay? And then you have to remove one hydrogen here and you have to remove the bond here, and then you have to, whatever hydrogen you removed here, add that hydrogen here. So now what I got the product, we have this benzene ring, then we have CH, we have OH, CH2, I'll write like this, then CO and then CH3. So here condensation water molecule will go, so we will get benzene and then C double bond CH and then CO CH3, right? So if you see C6H5, so here one more H is there, yeah. C6H5 CH double bond CH CO CH3. So the correct answer for this question is option number D. Aldol condensation is very, very important reaction. Please practice products from here and also from your cross aldol reaction. Okay, so this question was from your aldehydes and ketones chapter. Easy question. Next one, which of the following species has the lowest ionization enthalpy? So if bond order, okay, if bond order is less, then ionization, it will be very easy to break them. So ionization enthalpy will be less. Okay. So if you see O2, okay, O2 minus bond order is the least. So if you see O2 bond order, I have given you a table. For 14 the bond order is 3, for 15 the bond order is 2.5, for 16 it is 2, for 17 it is 1.5, for 18 it is 1. Now if you see O2, O2 is 8 plus 8, 16, bond order is 2. O2 plus 16 minus 1, that is 15, so that is 2.5. For O2 minus 16 plus 1, 17, that is 1.5. So since the bond order is minimum, it is very easy to break them. So the least bond energy will be for O2 minus. Correct answer will be option number D. Okay. Now let us see the next question. The rate constant for the reaction is this much. If the rate of the reaction is this much, what will be the concentration of N2O5? So very simple question from your chemical kinetics based on your rate law. So we have been given, so I can write rate is equal to K into concentration of N2O5, right? So what is the value of rate? Rate is 1.4 into 10 to the power of minus 5, and we have rate constant is 2 into 10 to the power of minus 5, concentration N2O5. Now how can you say that this is a first order reaction? Like how I can take order as 1? Because if you see the rate constant unit is second inverse, right? And we know for K second inverse unit, if it is there, then it is a first order reaction. So now if you can calculate the value of N2O5, so we'll get 1.4 by 2, so that is 0.7. So the correct answer for this question will be option number B. Okay, next question. The mass ratio of aluminium and silver deposited using the same quantity of current. So this question is from electrochemistry, Faraday's law, right? So we have this formula, Faraday's second law is M1 by M2 is equal to E1 by E2. What is E1 and E2 here? Equivalent weight of 1 by equivalent weight of 2. So the question is asked the mass of silver and aluminium. So let us write mass of aluminium deposited by mass of silver deposited is equal to equivalent weight of aluminium by equivalent weight of silver, right? Now what is the formula for equivalent weight? Equivalent weight is molar mass by n factor, right? So for aluminium, what is the molar mass? 27. In aluminium, the charge is 3 plus, right? The n factor is 3. So I can write this one as 27 by 3. And for silver, the molar mass is 108 by 1. So that is 9 by 108. So the correct answer for this question will be option number A. Very easy question. Next question. So 10% solution of urea is isotonic with 6% solution of a non-volatile solute X. What is the molecular mass of the solute X? So this question is from solutions chapter. Topic colligative property, and then in that osmotic pressure. Isotonic means the two solutions have same osmotic pressure. So I can say pi 1 is equal to pi 2, C1 RT is equal to C2 RT, C1 RT we can cancel, so I can say C1 is equal to C2, right? Now C1 is what again? Number of moles of this one will be equal to number of moles of this one. So if you say for 10% of urea, so number of moles is what? Given mass by molar mass. 10% means 10 gram of urea is present. So given mass is 10 gram, molar mass of urea is 60. Is equal to 6% of a non-volatile. So given mass is 6 and molar mass we have to find out. So now if I solve this, we will get, we can cancel this one, that is 36. So the correct answer for this question will be option number C. Okay, this is also very easy question. Next, which solution has the higher vapor pressure? Okay, so whenever a solute is dissolved in a solvent, the vapor pressure decreases, right? So that is called as a relative lowering of vapor pressure. So if any ionic solute is added or electrolytic solute is added, the decrease in the vapor pressure will be more. But the question is asking for highest vapor pressure, so we have to select such type of solutes which doesn't produce any I value or doesn't dissociate. So if you see, glucose is the one where there will be no dissociation, I value will be 1, here the I value will be 2, here the I value will be 3, here the I value will be 3, here the I value will be 4, right? But here the I value will be 1. So the correct answer for this question will be option number B. Okay, next question. Acetic acid can be halogenated in presence of phosphorus and chlorine. Formic acid cannot be halogenated with the same way because. So this question is from your aldehydes, ketones and carboxylic acids chapter, right? So this is your HBZ reaction whenever there is an alpha hydrogen that can be replaced with your halogen group, right? So that is because of presence of alpha hydrogen atom in acetic acid. Absence of alpha hydrogen, this statement is wrong, this statement is wrong. So the correct statement for this question is option number B. Okay, so the reaction, if you have remembered, it is like this. If you treat with this one, they will get, right? So this alpha hydrogen must be present. But if you take formic acid, which is your HCOOH, right? So this is not alpha hydrogen. Alpha hydrogen is the hydrogen attached to the carbon next to the acidic group, right? Okay, next. For which of the following solutes the Van't Hoff factor is not greater than 1? Okay, so here the Van't Hoff factor is 2. So this question is again from your solutions chapter. Here the Van't Hoff factor is 3. Here the Van't Hoff factor is 5. Here the Van't Hoff factor is 1 because it is a non-electrolyte solute. So not greater than 1. So the correct answer for this question is option number D. Okay, next. Amino group is orthopara directing for electrophilic substitution reactions, but on nitration the major product is meta-nitroaniline. What is the reason for this? So this question is from your amines chapter. Very important reasoning, this one. Now when you take with aniline, okay, and when you do nitric acid, so if you remember what is the reagent for nitric acid, for nitration, that is concentrated HNO3 and concentrated H2SO4, right? So it's a highly acidic medium, H plus is there. So what happens? This nitrogen lone pair gives and accepts one H plus. So what does it form at that point? It forms, okay. Now this one is now having a plus charge, which is the electron withdrawing group, and electron withdrawing group, as we know, are meta-directing. So that is because aniline gets protonated with strong acids to give anilium ion, which is meta-directing. Okay, so the correct answer for this question is option number A. Next one. In a chemical reaction, the rate constant of the backward reaction is 7.5 into 10 to the power of minus 4, and the equilibrium constant is 1.5. The rate constant of the forward reaction is. So this question is again from your chemical equilibrium. Okay, easy question. We know equilibrium constant is equal to rate of forward reaction by rate of backward reaction. Equilibrium constant value is given to you 1.5. Rate of forward we have to calculate, and rate of backward is 7.5 into 10 to the power of minus 4. So if you multiply these two, I will get 1.5 into 7.5. So that is your 1.125. Correct answer for this question will be option number C. Very easy and direct formula based question. Next question. Hydrolysis of an ester gives acid A and alcohol B. Okay. So you know, whenever esters are undergone hydrolysis, they produce an acid and one alcohol. So acid is your A and alcohol is your B. Now the acid A reduces Fehling solution. Okay, so this is one which can reduce Fehling solution. Okay, next what is there? Oxidation of alcohol B. Oxidation of alcohol B gives acid A. Okay, this is very important. Oxidation of this one will give you A. The ester is. Okay, so now if you see here, this one on oxidation gives this one, means both of them should have same carbon, right? So the carbon number present in the acid and the carbon number present in the alcohol should be same. That's why when you oxidize this one, you can get this one. So now if you see here, methyl formate, and one more, the acid which can reduce Fehling solution is your formic acid, right? Which can reduce Fehling solution is your formic acid. So now if you can write, we have this one HCOOH, and methanol will give you, methanol on oxidation will give you formic acid. So we can dehydrate it to get our ester, that is methyl formate. Okay, so the correct answer for this question is option number A. So this question was from your, this question is again from your acids chapter. Okay, so this is again important question. You remember the acid which can represent or which can reduce the Fehling solution is your formic acid. Next question. The molar conductivity is maximum for the solution of concentration. So the question is from electrochemistry. Topic is from molar conductance. What's the formula of molar conductance? Lambda is equal to kappa into 1000 by C. If concentration will be less, then molar conductivity will be high, right? So you can check the options. Option number D, concentration is minimum, molar conductance will be maximum. So the correct answer for this question will be option number D. Next, the question number 21, freezing point of an aqueous solution is given 0.186 and elevation of boiling point of the same solution would be. Okay, so we have this question from your solutions chapter, again from colligative properties. What is the formula of elevation in boiling point? Delta TB is equal to KB into M, and delta TF is equal to KF into M. We need to calculate the boiling point, right? Boiling point. So let us take the ratio of both of them. Delta TB by delta TF is equal to KB by KF, right? MM will get cancelled because it is the same solution, so concentration is same. Now if you put the value here, delta TB is equal to, delta TF is what? For aqueous solution, you can see it will be delta TF is equal to T naught of F minus TF, right? So 0 minus 1.86, that is equal to 1.86. So we can substitute here, okay, is equal to KB by KF. KB is 0.512 and KF is 1.86. So now delta TB value is how much? 0.512 by 186 by 100, okay, and we have this one, that is 186 by 1000. Okay, so I will just put the decimals here. So we can cancel it, we'll get 0.0512. So the elevation in boiling point will be 0.0512. The correct answer for this question is option number B. Okay, next. A chelating ligand has 2 or more than 2 donor atoms to bind to a single metal ion. Which of the following is not a chelating ligand? So thiosulfato, if you see, it is SO3 2 minus. Okay, so it is always a unidentate ligand. It doesn't bind from both sides, binds from only one side, that is your unidentate ligand. So that is why the correct answer for this question will be option number A. Even if you did not know this one, you should know oxalato, glycinato and ethane 1,2-diamine are your polydentate ligands. So that is why your answer will be option number A. Okay, next question. Which of the following lanthanide ion is diamagnetic? Okay, so atomic numbers are given. So Yb2 plus electronic configuration is 4f14. Okay, so xenon 4f14. So there is no unpaired electrons here, so it will be diamagnetic. So the correct answer for this question is option number A. Next, a nanopeptide contains dash peptide linkages. So this question is from biomolecules, very easy question. See here, suppose we have 3 amino acids. Okay, so number of, this is one peptide bond, this is second peptide bond. So number of peptide bonds is always 1 less than the number of amino acids, but we will call it as tripeptide. Okay, so there are 3 amino acids, so this is called tripeptide, and number of linkages will be 2 or number of peptide bonds will be 2. So when it is nanopeptide, there are 9 amino acids and it will be connected by 8 peptide linkages. So the correct answer for this question will be option number B. Very easy question. Next one, question number 25. A gaseous mixture of 2 moles of A. So A is 2 moles and 3 moles of B, and C is 5 moles and D is 10 moles. Okay. Now assume that the gases are ideal and the partial pressure of C is 1.5 atm. So we know the partial pressure of C is 1.5 atm. Calculate the total pressure. So what's the formula of partial pressure? Partial pressure of any gas is equal to mole fraction of that gas into P total, right? We have been given with the partial pressure of the gas. If we can find the mole fraction of C, then we can calculate the total pressure. So let us calculate the mole fraction of C. So what is the formula of mole fraction? Number of moles by total number of moles. So what is the number of moles of C? 5, and the total number of moles is 5 plus 3, 8, 9, 10 plus 10, 20, right? So partial pressure of the gas is 1.5 atm, that is equal to 5 by 20 into P total. So now if I solve this, I'll get 6 atm is equal to P total. So the correct answer for this question is option number B. Okay, very easy question. Next one, the end product in the following sequence of reaction is. Okay, so this question is again very easy one. So this is from alcohols, phenols and ethers chapter. Okay, so sorry, this one is from your haloalkanes chapter. Yeah, haloalkanes, reactions of haloalkanes and haloarenes. Okay. Now, if you see first one is chlorination of benzene. So first you have to add chlorine molecule. Then when you do sodium ether, so that is your Woods reaction. So what will happen? We will get 2 chlorine molecules, right? So the correct answer for this question is option number C. Okay. Next, the geometry of ClO4 minus. So this question is from your chemical bonding. Okay. ClO4 minus means there is total chlorine has 7 valence electron, but 1 extra electron is there, so 8 valence electron, and 4 oxygens are there. So we know each oxygen will form 2 bonds, so we can have the structure like this, right? So there are 4 sigma bonds with no lone pair, so the number is sp3 hybridization. For sp3 hybridization, the geometry is tetrahedral. Correct answer for this question is option number A. Next, which one of the following is wrongly matched? Okay, saponification of CH3COO-C2H5 is a second order reaction. This is correct. Hydrolysis, we know it's a pseudomolecular unimolecular reaction. That is also correct. Decomposition of H2O2 is a first order reaction. This is also correct. So you cannot have any way to learn this. Means you cannot guess it. You have to remember. Okay, so in NCERT examples, there are examples for 0th order, first order reactions. So just remember certain examples. That is very, very important for solving such theoretical questions. Now, if you see H2 and Br2, the order is H2 and Br2 is half order, right? So it is 3 by 2 or 1.5, but here it is given 0th order reaction. So this question or this statement is wrong. Okay. Next, which of the following reactions will not yield phenol? Okay, so first reaction we can have, in second reaction we can have, first it will be converted to benzene diazonium chloride, then with water we can get phenol. Here oleum is a very commercial method of preparing your phenol, but this one chlorine, okay, this one cannot be replaced with OH. Why? Because this has a partial double bond character, and we know this is sp2 carbon, so there are some reasons, like due to the partial double bond character, the CCl bond is very stronger than the single bond, so this bond will not break. So OH, that we cannot have a simple nucleophilic substitution reactions in this case. So the correct answer for this question will be option number D. Next one, hydrolysis of an ester gives acid A and alcohol B. The acid reduces the Fehling solution. Oxidation of B gives A. Okay, this question is already discussed, like just now we have discussed. So the answer for this question will be methyl formate. Okay, once again I'll tell your, so A is the acid, okay, and B is your alcohol. And the acid which can reduce Fehling solution is your methanoic acid. Okay, and the oxidation of this one is giving you this alcohol, means both should have the same number of carbons. So if we have this one HCOOH and we have here CH3COH, so this one will get reduced, so we'll get HC double bond O CH3. Okay, so that is your methyl format. Okay, yeah, so these were the first 30 questions of the mock test 1. So I hope all of you have attempted the test and then check your scores. So please comment down your scores, and if any doubt you have in any question, comment it down. I'll address it in my next video. Please join the WhatsApp channel. Once again, I'm repeating, it has 3 mock tests, very helpful for your exam. So please join it, and if you have found this video helpful, please like, share and subscribe our channel. Thank you.